Hello my dear students, in this class we will discuss about an different interesting and which look like difficult type of interference and this interference is taking place in the case of a wedge-shaped thin film. First we consider thin film with parallel. Now we'll consider a thin film which is wedge-shaped film. Wedge-shaped means one film will be like this, one film, another film will be like this. Means both will be in angle with each other. And listen, this angle is very small. This is just like this. Suppose angle is very less. Suppose I will consider this angle as alpha. Before going to wedge-shaped thin film, I will say you one concept, one theorem. Suppose this is an line. I will plot a normal to both the lines. This is one line, normal to this line, and suppose this is normal to this line. So remember students, if this angle is alpha, which is the angle between these two lines, then the angle between their normal will be also alpha. Remember this one, we will use this one in the wedge-shaped film. And one more thing, in the wedge-shaped film you will be thinking that simply we will take one plane like this, means one mirror like this and another mirror like this. No, this is not the case. We will have two mirror like this, two glass plate like this, and in between there will be some film. That film may be liquid, may be some oil, whatever be. This will be having an refractive index mu. So this will be your rarer medium. This will be your denser medium. These are the concepts behind the wedge-shaped film. Now we will see light will fall here. What will happen? Normal will be there. Then now what will happen? We will see now. Okay. I will draw wedge-shaped film in a big figure because in this lecture you only understand the wedge-shaped film structure. Then next we will go to the derivation. Okay. Fine. Light came. Suppose one monochromatic light source is coming here. I'll keep it more up. Visible clearly, and it will face a normal like this. So, what is the theorem? According to the theorem, when light comes from the rarer medium to denser medium, the light bends towards the normal. So that same thing will happen here. Light bends towards normal. So here also it will face one normal. Suppose this is normal N1, this is normal N2. I should write here. Once again this light will reflect. Here also same normal we can draw. And light will reflect here. Here also light will reflect. So this is the path difference. This delta is your path difference. One light is coming, this light is reflecting, and the part of this light is refracting, transmitting, and what is happening? This transmitting lines is reflecting again, and here this is transmitting. So these are two lines we are getting in parallel manner, and the source is taken as monochromatic. So their superposition, their interference will give us maxima or minima. We will see after calculating the delta. Let's complete the figure. I will extend this line in such a way that this one will be equal to this one, and I will connect this, and let's say up to this my thickness, and my thickness is E. If this one equal to this one, so these two angle will be same. And if this is a isosceles triangle, this one will be equal to this one. So this is also your E. This one I told alpha, and this is also alpha I have already told. Suppose your angle of incidence of the original beam be I, and this will be I also. So this will be, as this is perpendicular, this will be 90 minus I. This will be 90. If this one will be I, then only addition of this thing angle will be 180 degree. So like the same thing, this will be theta. You consider the angle of transmission as theta. This is theta means this is your 90 minus theta. I will draw one perpendicular from this on this line. So this will be 90 means this should be theta. Then only addition of this angle in this triangle will be 180. See, this is theta and this is theta means which one will be theta? Your figure is something messed up, that's why I can't getting. For this is theta means this will be theta. Yes, right. See, this is a triangle. Like this. Your this angle is theta. This angle is your alpha. So this angle will be theta plus alpha. That is your this angle is theta plus alpha. This is incidenting, this is reflecting. So this angle will be equal to this angle. This is also theta plus alpha. Like the same thing. This is the addition of this angle, this angle. Here also same type of triangle we can draw. So addition of these two angle will be the total one. That is 2 theta plus alpha, and we know these both will be same. So this is theta plus alpha. This is also theta plus alpha. This is all regarding the structure. Light is coming, incidenting with an angle of incidence I. Then that same light is transmitting with an angle of transmission theta. Then the normal drawn to these two lines joining, this is the having an angle alpha, and these two adding to give theta plus alpha. As this is your incident and this is the reflected, this angle will be equal to this angle. So this is theta plus alpha means this will be theta plus alpha. These two combining to give 2 theta plus alpha, and isoscale angle. So these two angles should be same means this is theta plus alpha and this is theta plus alpha. This is I means this is on right triangle. So I means this will be 90 minus I. This is 90 means this angle will be I. This is theta means this is 90 minus theta. This is 90 and this will be theta. And the thickness I have considered E as isoscale angle. So this line will intersect this line in at the half. So whatever this will be, the same thing it will be. E, this is E. This is the structure, this is the figure of the wasted film. Now we will proceed towards the derivation of this wasted film. And try to remember this figure, or else while you are practicing, draw it in a rough paper, then go to the expression, derivation. You can understand easily. So I am keeping it inside, just whipping out this much so that I can do my expression. So remember that this light is coming, and now we will do the before going to the derivation part, I would like to name all the points because this is already messed. So if only I will give the name, then only I can do it easily. Suppose I will take it as A, this is B, this point is C, and the D point is this one, and then this point is our O, this point is M, this point C already taken, this is N, normal, and AB, then this point B dash, 1 point left, this is, let's say, this is E. So point ended, A, B, C, D, E, this is B, this is B dash, this is O, this is M. Now we will go to the derivation part. So before going to the derivation, I will give you one tips that what is the difference, path difference, when we will get the path difference. Whenever there will be some difference in the path covering, then only we can calculate the path difference. What we are getting? We have one wave here and we have another wave here. These two waves are running. Let's assume that there is two boys running. One boy is going like that. Suppose one boy is going in a curved path, one boy is going in a straight path. So I will keep one checkpoint. So at the checkpoint, I will see at what time difference the both boys are passing the checkpoint. So if I will subtract this 2 time, I will get the path difference. Now these two are the two boys. This is one boys and this is two boys. What is happening? These two boys, from this point, this boy is going through this way, but another boy is going through this way. Coming BC, then CB dash, then going. That means when this boy is covering this path, this boy need to cover this much long distance. So if I will subtract addition of these two, from this one, then only I will get the path difference. That means that this is happening in the case of medium, this is happening in the case of vacuum or air. So I will take it as the first medium and I will take it as the second medium. From this one I wrote, that is the difference between the path covered in the film, means this much, and divided minus this much. That is our path difference. And according to the rule of refractive index, you know, the refractive index is the speed of light in medium 1 divided by speed of light in medium 2. That same thing I wrote here. I am not writing. I have already written. So if I will multiply time in both the cases, I have a stopwatch and I am watching how the boys are running. And I kept a fixed time. How they are running, how much they are running, then only I can subtract to get the path difference, to calculate the path difference, then only I can show whether they will, suppose they will overlap with each other, whether they will overlap constructively or destructively, that same thing we will get here. So I multiply time, velocity time is nothing but our distance. So that is distance covered in the first medium whole divided by distance covered in the second medium. Why I calculated this one? As one path is occurring in the one medium, means rarer medium, and another path is covering in the denser medium. That means medium is different. So we should have a relation between two type of medium by introducing the refractive index. That's why I calculated this one. And calculating this one, I got your distance covered in first medium equal to distance covered in second medium into refractive index. That means what is the second medium? This is first medium, second medium. If I will multiply your refractive index mu with this one, then I can remove these terms. Means I had written here film, I had written here air. After introducing mu, I got a chance to remove this part because I got an equilibrium between these two. How the both are interrelated. I got the expression including the refractive index. Now simply I multiplied the refractive index with the both the terms mu bc. Actually guys, I am reading all these things then explaining, else I need to do the videos of 1 hour like that. So better I will do this. You can write in the note paper, then you see how I am telling. You can notice on my speaking. So I multiplied this mu with all the paths. Wherever I need to multiply, means whatever happening in the film, I need to multiply with mu. So what happened? BE, this BC. How much is this BC? BC is nothing but your BE plus EC. Are you getting? Here we have a point E in between BC, so I can write BE plus EC. Instead of BC, I wrote BE plus EC. Now CB1. Your CB1. What I told, this one will be equal to this one. So instead of CB1, I can write CO. That same thing I wrote here. Now what happened? BE remain as usual. Then this is EC. This much, and CO this much. This much plus this much, so it will be EO. See, EC, CO, total is EO. So this one you understood. Once again I multiplied. Now I will consider two triangle. These things I have already done in the thin film, parallel thin film. This type of expression I have already done. So first I will consider this triangle. This is a right angle triangle. This is 90. So BD-B1 triangle, your sin I is nothing but sin theta is perpendicular by hypotenuse. So BD, this is perpendicular by hypotenuse. The same thing, I will take one more triangle, that is this one. This is BB1E. So your theta will be, sin theta will be perpendicular by hypotenuse. Your perpendicular is BE and hypotenuse is BB1. These two expression I got. I should erase this part. So now your refractive index will be sin I by sin theta. So how much is your sin I? BD by BB1 into sin theta will be reversed. So I will write BB1 by BE. These two get cancelled. So your mu BE equal to BD. So instead of BD I can write mu BE. Instead of this BD I can write mu BE. This term get cancelled. So only left your delta equal to mu EO. Now if I will calculate this EO, then I will get the path difference completely. So let's have a look on another triangle. This is 90. This is a projection on this line. So this is 90. This is an triangle. So this is theta plus alpha. I will take this triangle now. Triangle EOB1. So this is triangle EOB1. I will take cos theta plus alpha. Base by hypotenuse. The formula is base by hypotenuse. That is EO by B1O. Okay. So your EO will be, how much is your B1O? This is E and this is E. I had already told why this is E, this is E. This one I have considered width and this one I have got from this one. So this one will be 2E, B1O equal to 2E cos theta plus alpha. This is the value of E. If I put this value in case of EO, your delta will be 2E mu cos theta plus alpha. See guys, I got an expression between the path difference. Means this path difference I got, this delta amount I got now. Now I will compare this delta with whatever I have got in the previous expression, previous experiments, n lambda, 2n plus 1 lambda by 2. Then I will compare at what point I am getting the maxima, at what point I am getting the minima. In the thin parallel film, we have already saw that whenever your path difference is 2n plus 1 lambda by 2, you have maxima. That means whenever this one means 2E mu cos theta plus alpha will be 2n plus 1 lambda by 2, you will get a maxima, means a bright fringe. Whenever you will have theta equal to delta equal to n lambda, you will get as minima. This is something different than the Young's double slit experiment. In the Young's double slit experiment, you are getting maxima in this case and you are getting minima in this case. So try to remember these things, these are a little bit different. So whenever you will have the calculated path difference equal to n lambda, you will get as your minima. This is for maxima. So this is a wasted film. We first explained about some theorem, some principle that is applied on the wasted film. What is wasted film, you guys know. Then how these things is operated, these things are explained. And I explained how I am getting the path difference, how to get the path difference. So have a look on this video and practice it on and do it. Take a big paper and do it neat and clean. Then only you can understand. This is very important and keep your practice. Thank you so much.